So now that we've seen all the properties for our quadrilaterals, we're going to be adding in 6-7 the ability to determine what kind of quadrilateral it is if I have those in a coordinate system. So that's polygons in the coordinate plane. So skipping through that first few questions, what we do need that's important here is that we can classify figures, again, if I use a coordinate plane, xy plane, if I remember that we first have to use formulas for slope, distance, and midpoint. So these three you've probably seen. Again, we have the distance, midpoint, and slope formulas there. And some things that they're used for, again, we have off to the right. So if I want to use the distance formula that can measure the distance of a segment, that's going to be helpful to find if sides are congruent or if diagonals are congruent. We can identify what shape it is. For midpoint formula, we can tell, again, if I have the midpoint of a side or whether diagonals bisect each other, which will help prove a parallelogram. And slope formula, we can tell if I have parallel or perpendicular. So that's going to be used for sides or diagonals, or again, the perpendicular diagonals or sides. So trying that in practice, first problem is asking us if ABC is scalene, isosceles, or equilateral. And it's giving us coordinates for A, B, and C. So after filling in that triangle, again, if I have 0, 1 for A, 4, 4 for B, 7, 0 for C, if I want to tell if it's scalene, isosceles, or equilateral, what that's asking us is about the sides. So characteristics of scalene is that no sides are the same. There are none that are congruent. Isosceles has two sides that are congruent, and equilaterals when all three sides are congruent. So if I want to find if the sides are congruent, that's going to be used with the distance formula. So distance formula for AB, again, I'm just using the coordinates from A and coordinates from B, plugging those into my distance formula, and if I simplify that, we get a distance of 5 from A to B. Trying that from B to C, again, same distance formula. If I plug that in, I also get a distance of 5. So at this point, we know it's at least isosceles. When I try to do that same distance formula for AC, we see that distance is not the same as the other two. We actually simplify to get 5 rad 2. So if I have two sides that are the same and the third one is not, we can tell that is an isosceles triangle. So next question asks us if we have a rhombus based on that figure, again in a coordinate plane. So a few different ways to tell. We could tell if it's a rhombus if I find the distance of all the sides. I can tell if they're the same. But something that's a little bit quicker is if I look at the diagonals, what we can remember is that the diagonals of a rhombus should always be perpendicular. So if I use the slope formula this time, again, if I want to test perpendicular, that's talking about their slopes. So if I find the slope of BD, again, plugging in those coordinates into my slope formula, I get a slope of -3/2. But if I look at the slope of AC, that's 5/6. So since I can tell that these slopes are not opposite reciprocals, again, if I had -3/2, the perpendicular slope would have been 2/3. I flip that and I change the sign. I see that these are not opposite reciprocals, so no, that's not going to be a rhombus. Since the diagonals are not perpendicular, there's no way I can follow those rules for a rhombus, so it can't be a rhombus. So next page we're looking at, if I'm looking now at a kite, we're asked for the most precise classification of the quadrilateral form if I connect the midpoints of these sides. So this way it's a little bit easier to tell what formula we're using. If it mentions midpoints, then that means we might be looking at the midpoint formula. And if I need the midpoint of each side, that just means I'm going to have to use that 4 times. So first thing I did is just list the coordinates there to start with. And that way, if I'm just using the midpoint formula, again, midpoint of Ki, I can plug in those parts into the midpoint formula. We find the midpoint is -2, 2. Using the same formula for your other sides, we get a midpoint of 4, 2, a midpoint of 4, -2, and a midpoint of -2, -2. So also, it's nice here that we have straight vertical lines and straight horizontal lines if I connect those midpoints. And if we draw the figure, we can see, don't really need to do second formulas for this. I can see that opposite sides are congruent, and I also know that these are going to be perpendicular if I have a vertical and a horizontal. So if I have a parallelogram, because opposite sides are congruent, and I know that I have right angles because my corners are perpendicular, that tells me that I have a rectangle. So I also can tell that it's not a square because those sides are not the same all the way around. So from left to right is a little bit longer from going up and down, so I can tell that that's a rectangle, not going to be a square. So last problem here that we're covering, this time we're talking about an isosceles trapezoid. So first thing is that if I have those vertices drawn in, you want to make sure you have those in the right spot. 0, 0, 2, 4, 6, 4, and 8, 0 for A, B, C, D. First thing we can tell is the parallel sides. We don't really need even the slope formula for this. If I can tell that BC is horizontal and AD is also horizontal, you can save yourself the trouble of doing the slope formula, and we can tell that these are my two parallel sides because those are both horizontal lines. So then if I want to find the midpoints of the legs, again, the legs mean the segments joining your two parallel bases. So AB is a leg and CD is a leg. And again, if it just says midpoints of those sides, that's a hint that we're just using that midpoint formula. So using the midpoint formula with our coordinates for AB, I see at the midpoint is 1, 2. Same formula for CD, I get 7, 2 for a midpoint. And after I have those midpoints drawn in, I just want to make sure if I'm finding on part 3, or I guess the third part of that question, the length of that midsegment is just drawing a segment, again, from the midpoint to midpoint. So this one also, we might have to use distance formula if it wasn't horizontal, but since it is just a direct horizontal line, I should just be able to count. Length of that midsegment is 1, 2, 3, 4, 5, 6. And again, if I had some, so say if I had a diagonal line, might have to use a distance formula on that type of question, but this makes it a little bit simpler. Don't want to make it too hard on yourself. If I have horizontal lines, I can just count the distance over. That would just be a distance of 6. So make sure you're able to use the midpoint, the slope, and the distance formulas, and we're going to use those to solve some questions in the coordinate plane.